Okay. Picking back up in lesson 5.1, we were talking about mean value theorem and Rolle's theorem, if you recall. And in both mean value and Rolle's theorem, remember we talked about that the function or the graph had to be continuous and differentiable.
Please pardon the interruption. Would Gabe Morley and Caden Bowers please report to the cafeteria? Gabe Morley and Caden Bowers, please report to the cafeteria immediately. Thank you.
Immediately.
Okay, so the function has to be continuous on the closed interval, differential on the open interval. That is true of both. Mean value theorem just says there is, on the certain interval a to b, there is some point c where the slope of the tangent line is equal to the slope of the secant line. Okay? The Rolle's theorem specifically talks about the fact that there is a spot where the tangent line, or that specifically the tangent line and secant line have a slope of 0. So they are horizontal lines there. Okay? And that's because your f of a and f of b are equal. So those were the two pieces we were talking about. And we are ready to talk about example 2. So let f be the function given by f of x. Find the number c that satisfies the conclusion of Rolle's theorem for f on -3, 1. So, first thing I just mentioned, in order for us to even consider Rolle's theorem, the function has to be continuous and differentiable. What do you notice about that function?
It's continuous.
Okay, it's continuous. Differentiable?
I think so.
Okay. And we could look at this two ways. One, what is that a graph of? X squared plus 2x minus 3?
Right.
It's a parabola, yes. So a parabola would be differentiable. But we can even more generalize that f of x is a polynomial. Anytime it's a polynomial, that is a valid argument that because f of x is a polynomial, I know it's continuous and differentiable. Okay? So one thing I'm going to state here is that f is continuous and differentiable because f is a polynomial. Remember, if it's a polynomial, it's terms added and subtracted together with only positive exponents, positive whole number exponents. No negative exponents, no fraction exponents, so we can't have x's in the denominator, we can't have square roots. Okay, so that's one thing. In order to be able to use Rolle's theorem or means theorem, we have to be able to state that f is continuous and differentiable. Okay, Rolle's theorem, in order for a Rolle's theorem to apply, my endpoints have to be the same. So in order, when we talk about Rolle's theorem, we need to find our endpoints.
Sure, just please pardon the interruption. At this time, the following students please report to the cafeteria: Jacob English, Vincent Cook, and Jason Courtney. Again, at this time, with the following students please report to the cafeteria: Jacob English, Vincent Cook, and Jason Courtney. Thank you.
Look at what someone left a big mess. And the first two are now blaming the other three, right?
Yeah.
Isn't that what's happening? The first two got called back because they were reported to have left the mess. But now they're blaming the other three or saying, well, they left it too. That's my guess.
Jacob did appear to have a devious look when he came to the restroom.
So I'm guessing it's a mess in the cafeteria.
Yeah.
Okay, so endpoints. We need to know that they're equal. So we need to find f of 3 and we need to find f of 1. Now, I'll be honest, it's not that you necessarily have to show the work here necessarily, but we can. Oh, this is not what I did for my second piece. Oh well, this was my third piece. Whatever. Okay, what is negative f of -3 when you put it in? 0? And what is f of 1?
0.
It is also 0. So right there we know that f of negative 3 equals f of 1. So those would be the endpoints of the secant line. And so since they are at the same level, that means my secant line is going to be horizontal and have a slope of 0, right? Now, so I'm looking back to see why would I have done this in that order? Okay, so our job is to figure out where this value of c could happen. So we need to know where our derivative is going to equal 0, because we want to know when the slope of the tangent line is going to equal 0. And that is when our derivative equals 0. So let's start by what is f prime of x? 2x plus 2. And then how can we be serious and do calculus, right? And then if we set it equal to 0, not 0, what am I doing here? No, that's supposed to be a 0. I just am messing up my own notes here big time. Yeah. We want to know when f prime equals 0, so 2x plus 2 equals 0. What do you come up with? X equals negative 1, correct?
Why are we setting it equal to 0?
Because with Rolle's theorem, we're specifically looking for the spot where the derivative equals 0. Okay, because we want our slope to be 0. Yeah, derivative of the tangent line needs to be 0 there. Now, why? I'm not liking the order I did here, but okay. Sorry, these extra zeros are throwing me off, and that's what's throwing me off here. Okay, final piece is we have to look and see where the slope of the tangent line and where the slope of the secant line are the same. Okay, so at what c value? Basically, when they're both going to equal 0. So when we do this, slope of the tangent equal to the slope of the secant, so f prime of x is how we would do the slope of the tangent. Slope of the secant, realizing that's going to be doing f of b minus f of a over b minus a. Now, what was f prime of x? F prime of x was the 2x plus 2, right? F of b minus f of a over b minus a. Well, what are b and a actually? B and a really are 1 and negative 3, if you will. And so with that in mind, f of 1 is 0 minus f of negative 3, which is 0, over 1 minus negative 3. Zero minus 0 over anything is going to be 0. So then we end up with that x equals negative 1, and this is our c value.
So why did we put both of them up there?
What, this and
Yeah.
this? That's what I'm trying to figure that out myself at this exact moment. Was
We just do one.
this part necessary? And that's why do I have that in my notes? At the time, there was probably a reason. But what was that reason?
Time was hidden. The answers are there.
And I don't have, so until I come up with the why, I do feel like this might not be required. Other than maybe it's just looking to find that there is a place when the derivative equals 0. But I'm not sure we would have to do that. Okay. Now, does this all... Okay, if we forget this part, and we don't worry about that part, does the rest of it make sense of what we're doing here? Okay, because we're looking for where we check to make sure it's continuous and differentiable. We check to make sure my endpoints were equal. Those two pieces right there allowed me to continue with Rolle's theorem. And then Rolle's theorem is, okay, I'm looking for the location where the slope of the tangent equals the slope of the secant, and what that's going to look like. So, and if you think about this, this is a parabola, right? This is a parabola who at f of -3 and f of 1, the parabola goes through those points. Well, guess what? At -1 is your vertex. And what is this? This is that's your minimum point where there's going to be that horizontal tangent. Okay, so if that visual helps a little bit. Because the x-axis, this would end up being your secant, that would end up being your tangent. Okay? Okay, other questions? Yeah. I'll leave that as optional for the moment until I figure out why I had it in there. And I don't have that reason yet, so. Okay, maybe they'll appear when I get down to another problem. Okay, example 3. I laugh because this problem always appeared in my previous calc book too. Okay. A sports car speedometer registers 50 miles per hour as it passes a patrol car stationed at a mileage marker. 4 minutes later, the car passes another patrolman at a marker that is 5 miles from the first. The driver notes that the speedometer registers 55 miles per hour. Can the highway patrol use the mean value theorem to prove that the driver was exceeding the speed limit of 70 miles per hour at some time between the two mileage markers?
Well, dang, where do you get a 70 mile per hour speed limit? Lucky dog.
On the interstate.
Yeah. I thought interstates were like 65.
No, there's
Some of them are 70, depending on where you're at.
Okay, that makes me feel a little bit better. And you.
It makes for fun drives down.
Some of them are 70, not all of them. You have to be at the right spot. Define speeding.
Are you a speeder?
Pause the recording.
Define
real quick.
speeding.
You have a lead foot?
I can, but define speeding. I mean, is speeding going
Like-
56 and a 55?
No.
Okay.
I'm saying like going.
My goal is always to keep it within 10.
Over 9 in your mind.
Exactly. 9, you're fine, you know. I try and keep it, between
When you go on
7, 8, and
on
9.
600, what do you, like when you're driving on 600, where do you go? Do you go 45?
On 600?
Isn't this, the speed limit is 45.
The speed limit is.
I know that.
Yeah, so speed limit is 45, so I'm probably 50 to 55 there.
Okay.
So.
I like when we were all on vacation.
So, as opposed to, what class was it this morning? And someone said that they were going. They said something about, oh, I go 70 or something like that, and I said on a county road.
Yeah.
That's a little fast on a. I said it's one thing on an interstate when you've got flat surface, more room to navigate. County roads, that's a little dangerous.
And then probably
Driving fast is not cool.
Yeah, exactly.
So,
Look at there within like a minute. Oh, that's good.
I don't know.
okay.
The GPS time is not destination, it's a challenge.
Popcorn even.
I love the GPS by Durango though, because in Durango it will give you, I don't know. I mean, when we drove to Seeger, it probably had us 10 to 15 minutes extra this weekend because that's how the GPS on the Durango works. It's annoying, but I always compare off of my phone and big difference. So it's easy to beat that time. Okay.
It's a
That gym
challenge.
was nice for an elementary gym.
It was, yeah. But the high school team was playing in the elementary gym. So is there no high school gym?
There is. It was 9 minutes away from that place. I looked at it. We were just 9 minutes away from the junior high school. Senior high school.
I don't know.
Do what?
Yeah, we played at the elementary instead of
The-
junior high school.
The boys scrimmage this weekend. Yeah. I don't know.
It was weird.
Okay. Let's talk about
Speeding.
The race car.
the fancy red sports car here. Okay. So, as we look at this. Okay. We've got our car driving here, right? And when it passes, I'm going to call when it passes the first patrol guy, t equals 0. Make sense? And then it travels some time, and then it passes a second patrol person at, I'm calling that point B, and this is 4 minutes later, right? Or was it 5? No, 4 minutes. Talking time here. 4 minutes, but 5 miles. Okay, but I'm not to that right now. Okay. Now, and this is going to be essentially our S of t. Should we be talking about minutes here? Not really, because 50 miles per hour, 55 miles per hour, 70 miles per hour. So that time, instead of talking 4 minutes, what is that in terms of hours? 4 minutes out of 60. And 4 60ths can reduce to 1/15. So that 4 minutes is 1/15 of an hour, if you will. That's some decimal. I don't know what it is, though, but I'm going to the fraction right now.
0.66666. Repeating.
What was it?
0.066.
Oh, there's a 0 first.
Yeah.
Okay. I was like, it's not 0.6 repeating, so what did you just say? Got it. Okay. So, with this idea, okay, T is going to be the elapsed time in hours after the car passes the first patrol car. S of T is the distance, the miles from the first marker at time T. I don't know if I should write that down or not. I have that in my notes. I think with this being the first time we're doing this, I will. Whoops. So let T equal, I can't spell, elapsed. I don't think I still spelled it right. Elapsed time in hours after passing first patrol car. Now the S of t, I'm defining to use as my position function, right? And so that is the distance. We're going with in miles because everything was given in miles per hour, right? In miles from the first marker at time t. So the distance in miles from the first marker at time t. Or first patrol car, if you will. Okay. What we need to talk about here is our average rate of change. Okay. In order to talk about average rate of change, we're going to have to think about the function, the distance, right? So the distance evaluated at, what are my times? The s of 1/15. So in other words, the distance at 4 minutes later, 1/15 an hour, minus the distance at time 0. Over b minus a, right? So 1/15 minus 0. How are we going to find the distance at 1/15? Or I guess what was it given as? It was given, wasn't it? How far had we traveled? 1/15. How far had it traveled? 5 miles, right? So this is doing 5 minus, what was the distance traveled at time 0? That was 0, right? Over 1/15 minus 0. So I have 5 divided by 1/15. How do I do 5 divided by 1/15? 5 times the reciprocal. So 5 times 15 over 1. And what is 5 times 15? 75.
Wow.
And what is that 75? Miles per hour. So, can the highway patrol use mean value theorem to prove the driver was exceeding the speed limit of 70 miles per hour? Yeah. Okay. At one point, at least, the car had to have been going 75 miles per hour. Is it saying it went that speed the whole time? No. But at one point, that would have to be true.
Wait. This makes me want to try that on my own. Like,
Don't go to Kentucky. Sometimes there's 3 in a row in one spot.
but like, what if you do like? Oh, that's awesome.
Wait, so why did we have to do derivative?
We don't have a function to do derivative with.
They should fall in the river 50 and 70.
I know, like, if you want them to think you're not speeding, why would you?
Okay, so, yes, by MVT, mean value theorem, the car was traveling at least 75 miles per hour, right? Actually, I should just say was traveling 75 miles per hour at least once is what I really wanted to say there. At least once in the 4 minutes. Okay. Now, I want to say there was something in my previous book that said that something like that was admissible in courtroom. So,
Really?
What?
I don't know. I don't have any truth or anything behind that. But this type of thing would be admissible in the courtroom.
When it comes up that court.
Like if you get a ticket, when you get a ticket, you have an option. You can pay the ticket, and if so, you have to pay it by a certain date, which is your court date. If you don't pay it, you're expected to show up in court to argue why you shouldn't have to pay it. So
you
We
could.
use this in court.
Huh?
Is that what you said?
that's what my old tech health book said, is that this was usable in the court.
Oops, I fudged the numbers a little bit.
So,
Did my math.
Okay. Example 4. Let h of x equal, given equation. Find all values of c in the open interval 1 to 4 guaranteed by the mean value theorem. Okay, so my interval is 1 to 4. Okay, I need something for my benefit there, something to mark it. So what's the first thing I should probably double check in terms of mean value theorem? Is it continuous and differentiable in that area? And just visual check, right? It's continuous and differentiable. And that's something we want to check. Okay? Now, my endpoints do not have to be equal to each other in this one, right? But we are going to have to find the endpoints. So, and actually, I guess what I should have done, you want to get the rulers out again? F of 1 is right here, yes? F of 4 is right there. Okay, so what are we doing here? We're looking at a secant line.
He is.
And why am I using 1 and 4? Because that is the interval we are provided, right? Now, if we want to go ahead and do a little bit of side work, we can. Let's see. What is f of 1? Not f. What is h of 1? H of 1 is 1. What is h of 4? 4? Well, that was too easy. Okay. So we're going to need that information when we find the slope of the secant line, right? Average rate of change. We're also going to have to find the derivative of this. So I'm going to go ahead and do a little bit of work there. H of x, if you will, is 5 minus, I just rewrote it as 4 times x to the negative 1, because I am going to have to take the derivative of this function. So that's going to be the other part of this. So the derivative of h of x, h prime of x, let's see, derivative of 5 is 0. I brought that x to the top so I could do my derivative, and it's going to be 4x to the negative second, which could be rewritten as 4 over x squared if you want. Knowing I'm going to have to work with it, I kind of want it that way. Okay, so here's the idea. We are looking that we want the slope of the secant line to equal slope of the tangent line. And so it's the idea of h of b minus h of a over b minus a equaling h prime of x. So that's, you don't have to write that out every time, but that's what we're always trying to do. Slope of the secant line, so that's finding your average rate of change using those endpoints. And we're going to set it equal to the derivative of the equation. So h of b minus h of a, 4 minus 1 over 4 minus 1, equal to 4 over x squared, because I already did my derivative. So 4 minus 1 over 4 minus 1 is really just 1. If it's 1 equals 4 over x squared, how can I solve? I would multiply the x squared out of the denominator, and then x squared equals 4, and so x is officially plus or minus 2. Were you guessing or something? Now, what do we really need to note here, though? What's the only value that matters? Positive 2, because we're on the interval 1 to 4, aren't we? Okay, so really x equals 2 that matters. Does that seem right? If I draw a tangent line there, is that going to be parallel? Okay, but there's my official justification. So, find all values of c in the open interval guaranteed by mean value theorem. So, c equals 2 satisfies the mean value theorem here. So I'm going to say, therefore, c equals 2 satisfies MVT on the interval 1 to 4. Okay, are we making progress? Okay, 2 more, right? MVT allows us to identify exactly where graphs rise or fall. And this is, pair them up. Functions with positive derivatives are increasing functions. Functions with negative derivatives are decreasing functions. We've already talked about that, right? Okay, the idea that basically if the slope is positive, the line's going up, right? If the slope is negative, it's going down. So that basic information there. Now, example 5. Find all values between the x-intercepts for which Rolle's theorem holds for the roots of f of x and verify with your calculator. I don't know if I verified with the calculator when I did this. Okay, so if we're getting ready to talk about Rolle's theorem, we should probably ask ourselves what question? Yeah, is this continuous and differentiable? Huh? Yes. Yeah, and yes, it's continuous and differentiable because, again, it's polynomials. It's a polynomial, and polynomials are continuous and differentiable everywhere. So that is, continuous and differentiable. Because polynomials are continuous and differentiable. Now, as we look at this, we need to figure out, it says for the roots of f of x equals 4x squared minus x to the fourth. So we need to look at where the zeros are. Realize when it says for the roots, that's another way of saying zeros. So in order to find the zeros, we're going to set f of x, 4x squared minus x to the fourth. We're going to set equal to 0. What can I do with 4x squared minus x to the fourth? Yeah. Factor out x squared. How about, can I factor out negative x squared? Would you guys be okay? I guess it doesn't matter, but because my leading term is negative, I guess it's not going to matter. If I just factor out x squared, then this is what? 4 minus x squared, right? And then you could go ahead and set equal to 0 right here if you want, or you could continue factoring. I can say x squared equals 0, and I can say 4 minus x squared equals 0. What are my zeros going to be? X squared equals 0 gives me 0. And that 4 minus x squared becomes 4 equals x squared. And then square root of 4 is plus or minus 2. So those are my zeros or my roots. Now, okay, can you picture what this graph looks like? What's the highest power here? X to the fourth, yes. And that x to the fourth has what type of coefficient? It's negative. So what's the behavior? Okay, because it's an even exponent, it's either up, up, or down, down. Because it's a negative x to the fourth, it's going to be down, down. Actually, can I? Here, I'll put it over here. And it's going to have to touch the x-axis, or at 0, and at 2, and at negative 2. How's it doing that if it's going down on both sides? You were drawing it, Jacob. It's an M, right? Upside down W, if you will. Because one of the options for a x to the fourth is a W. Flipped upside down, it's an M.
How do you know it's going down?
Because it's a negative x to the fourth, so my highest power is x to the fourth, which is even, so that's either up, up, or down, down. Because it's a negative on that lead power, it's going to be down, down. Kind of like if it was negative x squared. We know that would be an upside down parabola, right? Because this is negative x to the fourth, we know it's upside down. Okay? So right there, those are my zeros, right? Those are my roots. And so with that in mind, we're looking for all the values between the x-intercepts for which the Rolle's theorem holds the roots. Well, first of all, my endpoints are going to be the same, right? These are all the roots. Those are all the same. You know, those are the same pieces. So in between the roots, we need to look at where my derivative equals, since it's Rolle's theorem, 0, because we want a horizontal tangent line. So let's look at our derivative. Let's see. F of x is 4x squared minus x to the fourth. So f prime of x is eight x minus 4x cubed. Set it equal to 0. Factor out a GCF of 4x. Two minus x squared, right? So 4x, 2 minus x squared. We set each part equal to 0. 4x equals 0. So we've got x equals 0. 2 minus x squared equals 0. So 2 equals x squared, or what is x? Not just square root of 2, but also negative square root of 2. Okay. These right here are my critical values, my critical points. They are places where my derivative equals 0. Does that make sense based on the graph I drew? Granted, my graph didn't end up very equal there like it should have, because it is a symmetric graph there, I believe, but does that make sense? Okay, the fact that, you know, square root of 2 is 1.4, so there's something in there and something in there. And again, my graph was totally a sketch there, wasn't it? It wasn't anything official. Okay, so how did they find all values, which rules room. So on the interval, oh, no, that's interesting. Does that one work too? I was thinking it was extra information, but does x equals 0 matter as well? That's a 0 tangent line also, isn't it? In my brain, I was going to rule it out as just extra information. I was just looking at the top, but that's another place that works. So for the interval, what interval did we end up on? We were on -2 to 2. So for the interval, -2 less than x less than 2, Rolle's theorem applies for x equals -2, 0, and +2. Did I have anything else there? No. Okay. Questions on that one? Okay. One more. Determine whether g of x satisfies the hypothesis of the mean value theorem on the interval 0 to pi. If so, find all numbers c on a to b such that g of b minus g of a equals g prime c times b minus a. Which, can you guys see what this is right here? First of all, there's a couple different ways I can point this out. First of all, do you realize that this is essentially saying, like, y2 minus y1 equals m times x2 minus x1? Do you see that connection? Now that I pointed out, at least. This is also, think about it, if you divide this b minus a back over, if you divide that b minus a back over, isn't that derivative of the secant line, or excuse me, slope of the secant line equaling slope of the tangent line? So that right there is the idea that g of b minus g of a over b minus a is equal to g prime of c, which I guess I was writing g prime of x, but it's the idea of some value c there. Okay? So we're just trying to basically prove that some value c exists that satisfies mean value there. Okay, they asked it fancy and all, but that's basically, you know, same thing that we've been working with. Okay? Now, we have to determine if this satisfies the hypotheses of mean value there. So, what's the first thing you're supposed to be checking? Is the function continuous and differentiable? Thoughts? We're assuming yeah. It's, well, it's kind of a polynomial. The plus 2x makes you think polynomial. But sine, what do you know about sine graph? Is it continuous and differentiable? Yeah. So this is where polynomials, sine and polynomial functions are continuous and differentiable. So sine and polynomial functions are continuous and differentiable. Gosh. Okay. Now, this is mean value theorem, not Rolle's theorem. So mean value theorem, I usually still go ahead and try and find my endpoints, but they don't have to be the same here. It's more of a finding my endpoints for preparation of the next piece. Okay, Rolle's theorem, the endpoints have to equal each other, right? Mean value theorem, I just usually find them. So I want to know what g of 0 is and g of pi, which those are my endpoints. What is g of 0? 0. Sine of 0 is 0 plus another 0, so that's 0. Pi.
0.
Well, sine of 2 pi is 0 plus 2 pi. And 2 pi is 2 pi. Okay, because sine of 2 pi is just another, that's the same as sine of 0, right? Okay, so again, if it was Rolle's theorem, those would have to be the same. It's just mean value theorem, so I'm just finding the endpoints. Because now, with piece 3, this is where we're looking at secant line and tangent line. Now, one thing I would go ahead and find, what is g prime of x? What is the derivative function? Derivative of sine of something, cosine of something, times the derivative of something. What's the something? 2x. Derivative of 2x is 2. So how do you feel if I go ahead and write 2 cosine 2x for that piece? Okay, the better you get at these, it is common to go ahead and put that 2 out front. Okay, so derivative of sine of something is cosine of something times the 2, plus derivative of 2x is 2. Okay, so if we're setting this up now, what are my endpoints? Pi and 0. So g of pi minus g of 0 over pi minus 0. We're saying that equal to x. Okay, or g prime of x, excuse me. If this works, that x value will be c. If we find something. So let's see. I already found g prime and g0. 2 pi minus 0 over pi minus 0 equals 2 cosine 2x plus 2. 2 pi minus 0 over pi minus 0 is going to be 2. 2 pi over pi, which is 2, equals 2 cosine 2x plus 2. What do you want to do? Subtract 2 would be an option. A couple different ways we could go, so that's what I was. Okay. So then I have 2 cosine 2x equals 0. You can go ahead and divide by 2, right? So then I have the statement cosine of 2x equals 0. I'm going to. Okay, do you remember how this works when you have that 2 in there?
Cosine inverse? Or like with the one, is that the one on the button? It's like the negative one?
You don't want to do cosine inverse. Well, maybe you could. I'm just trying to figure out how that would play out with the 2. I would use more this. I guess they're showing calculator here, aren't they? Why are they showing calculator? I wasn't using the calculator.
The first one said to verify.
It did. This one, maybe they just want us to verify. I don't know. So let's start with, when does cosine equal 0?
pi over 2 and
3 over 2
pi over
3 pi over 2.
Mm-hmm. So normally we talk about when does cosine equal 0, and that happens at pi over 2 and 3 pi over 2, yes? So the idea here is cosine of pi over 2 is 0, and cosine of 3 pi over 2 is 0. But what is in this place? It's a 2x. So if I then take 2x and set it equal to those, what am I doing with that 2 to solve for x? You're dividing by 2, which is multiplying by 1/2, if you will. So if I multiply by 1/2, we're going to get x could have been, or could be, pi over 4 and 3 pi over 4. We did this in pre-calc. It's been a hot minute, right? But we've done this. Now, what was my interval? 0 to pi. Are those both on this interval? They are, aren't they? Pi over 4, so 1/4 and 3/4 are both between 0 and 1. So we're going to want both of these answers here. Okay. Notice when we did this, pi over 2 and 3 pi over 2, technically 3 pi over 2 wasn't on our interval, was it? But we're going to use all of our normal answers going around the unit circle to decide before, because we weren't done yet. Okay. So, question yourself, are we on the interval 0 to pi, which is what we were given? And we were. So I'm going to finish this off and say, therefore, C equals pi over 4 or 3 pi over 4 on the interval 0 to pi to satisfy MVT, mean value theorem. Okay. Yeah, I'm honestly not sure why that one is calculator active. I guess, Ethan, we're going back to you want to use the sine inverse button. Maybe we should have, but then you end up with ugly decimal answers. So, yes.
When you use the -2 is less than x is less than 2, put that in the brackets.
Say what now?
So you can write it like -2 on the interval, -2 is less than x, less than 2.
Yeah, just like here, I could write 0. Those are interchangeable things at calc level. Okay, so interval notation or inequality notation.